Hello my YouTube friends, Sharky here, and I am back with another shaky cell phone video. This time, it's about this here linear power supply. So in my last video, I mentioned that 65 volt power supplies are kind of hard to find. Well, I'm eating my words on that, and I'm glad. I'm really glad that that's happening, because I thought this was a unicorn. I thought this didn't exist. So this here is a 65 volt linear power supply, good for about 24 amps. There's the website I got it from. There's the part number. There's the specifications. And 24 amps at 65 volts, that's not bad. But I want to put it through its paces, and I want to see how much current I can draw, how much ripple I get, and kind of test it in an application with a single device, a single transistor Ldmos palette, and see how it does. So right now, with the input voltage being smack dab 120, we're getting 65 volts out, which is pretty good. It may end up that we need a higher resting voltage, but I can't see any reason why this is not going to work. So give me a few minutes, I'll plug it in and try it. A few other things to mention. This transformer is double winding, so 120 or 240 volts. And this transformer has also got another secondary. It's got a 12 volt and an 18 volt secondary, though, that orange and brown wire right there. So if you wanted 12 volts and a little regulator just for your amp projects, it's always good to have 12 volts around, because pretty much everything in radio runs on 12 volts. So these power supplies are actually kind of modular, so you can get them with different regulators and that's the word I'm looking for, rectifier boards. So these boards that are installed here are just rectifier boards. They've got some filter capacitors, they got a bridge rectifier in there, and that's it. But they've also got another one that drops into that spot over there with a 12 volt linear regulator, a 7812, or whatever that super common regulator is. And it's just a little module that drops right in there, and you just connect the secondary right over to it and go to town. So I'm super stoked I found this. By the way, this is cost me $250 to my door, give or take a few bucks, about $250 to my door for 24 amps of linear, unregulated 60, 63, 65 volts. So yeah, I'm gonna test this bad boy out and see how it does. Let me rearrange my bench, and we'll get down to it. All right, so pardon the mess. There's a lot of wires going in all different directions, but I'm gonna do my best to explain what I've got hooked up here. So this power supply is currently running off of, do you recognize that plug? 240. So ground wire for safety. My name is not Electro Boom. It might be one day, but today is not that day. We have got a 50 amp analog meter here, current shunt. So that's kind of weird how I had to hook it up, a bunch of small wires into a couple of big wires, but you get the idea. Voltmeter, so this is monitoring the voltage at the power supply before whatever little tiny bit is lost in the wires there. This is bird watt meter. We're going to put it in average for now. 1000 watt slug for reference, so you can see approximately how much power we're getting for how much current draw and all that good stuff. What do we got going on over here? Okay, so on the oscilloscope, this yellow line, my channel 1, that's our RF, so we're going to monitor our modulation. And this blue line up here, I don't know why you're going to see it because it's kind of hidden by a cursor, but that is our voltage. So that is channel 2 here, and that is winding its way around to this probe. So ground to ground, and then the tip of the probe is going over to the positive voltage on the power supply, so that we can take a look at the ripple. So long story short, the yellow cursor is our RF and our modulation, and the blue cursor is the ripple in the power supply. So there's going to be a little bit of RF transposed onto the ripple, just because not everything's perfectly shielded. RF gets in any little spot, but you get my point. Let's fire it up. I think I'm going to start with a pretty normal carrier for this box. So this is a 1 transistor Ldmos MRFX 1K80H, and it's almost identical to this palette sitting here. So if you watch my last video, I think did I turn this palette on? I don't know. This is very similar to most of the other palettes that I've made, but it's kind of optimized in a few ways. This palette here is basically the same thing for all intents and purposes that's in this box. So this palette maxes out around 2K. You can get a little more from it, but your waveform starts getting distorted. So let me start with kind of an AM radio situation. So this power supply is good for 24 amps, sticker price, sticker current, so to speak. And I'm probably not going to push it much farther than that because you shouldn't push stuff past its rating, bottom line. So we'll crank it up to a 400 watt AM carrier, which in my opinion is just about right for this box at 65 volts. And we'll take a look at the current, the voltage, all that good stuff, and then we'll turn on some modulation and take a look at the ripple and see how much it's dipping the power supply voltage. All right, what do we got over here? I can turn my modulation off. All right, sorry for the fan getting a little loud, but that's our dead carrier right there. That's the ripple that we're seeing in the power supply. That's the current that we're drawing, right about 15 amps, 61 volts according to that meter, and a little shy of 400 watts, 350, 375. So that's actually not too bad. That's really not bad at all. Let's turn on some modulation and see what we get. Not too bad. Still maintaining an average of 60 volts. We've got an average of 19 amps. And let me click this into 2x in peak mode. What is that, 1800 peak watts? That is not bad. That is not bad at all. I think that this single module right here is perfect for a single box running AM. Maybe not sideband. If we were to run this on sideband, we would start to draw a lot more current. Same thing would be true if you're trying to run FM, which this is a 27 megahertz box. I hope you're not trying to run FM. You could, but I hope you're not. So with AM, I think this power supply is absolutely sufficient to run this box and to run this palette. And that's not bad considering it's only 250 bucks. So one of my biggest concerns when I got this is that unregulated power supplies have ripple. They have 60 hertz ripple, or 120 hertz rather, 120 hertz ripple. And I was concerned that that 60 hertz might transpose itself onto the modulation, or onto the carrier. So that's the ripple on the power supply. And as you can see, our modulation is, or not our modulation, our carrier is pretty flat. It's pretty flat. I'm sure there's a little bit of 60 hertz tone making it onto the carrier and out into the ether. But, really not enough to make a difference. And besides, most radios are filtered. They'll filter 60 hertz out, no problem. It's when you start getting harmonics of 60 hertz that it actually starts coming through the other end. But a pure 60 hertz tone should be filtered out by any normal radio. So I think it's great, man. I am super excited that I found this power supply because now I can recommend them to you guys and say, hey, here's a 65 volt power supply that is sufficient for running a 1 transistor palette. If you wanted to be on the safe side, like if you really wanted to run FM or something, then there's no doubt that you would need 2 of these to get the current. These power supplies, if you go to their website, they say that they're quite capable of momentarily exceeding their current rating. And I still wouldn't do that. You could if you just wanted to key down for like 15 seconds and then call it a day, but it's never a good idea to go past what the sticker says. So 1 transistor, AM, 65 volts, that's your unit. I'll take a picture of the sticker again so that you guys can see the website, and of course browse around at their other products. They have other voltages, other sizes, and they have other options. You can buy this power supply with a 12 volt regulated supply, you know, for running your relays and anything else that might be 12 volts in your build. Hooey! By the way, I am no way affiliated with this company. I just Googled it after making my last video. I was like, man, there's got to be something. There's got to be a 65 volt power supply. So I got on the Googler, and through a transformer that was listed on eBay, I stumbled across this guy. So super stoked about that. And yeah, I'm Mud Deck Sharky. Hope you enjoyed the video. Hope you found something useful. And I'll be back again soon. Thanks for watching.